Hello guys, in this video we're gonna learn a new method to solve electric circuits. So last time we learned the superposition and before that we learned Kirchhoff voltage law, Kirchhoff current law and Ohm's law, and all of these are methods to find the solution of electric circuit. Today we're gonna learn a new one which is called the Thevenin theorem or Thevenin equivalent. Okay, so it's another way to find or solve electric circuit just like the superposition. Of course, a different approach. Okay, and again, all of them should give you the same answer. Okay, so what is Thevenin is saying, or what is Thevenin theorem is saying? It says that if you look into the circuit, into any circuit between two terminals, like for example A and B in this case here, okay, these two terminals A and B, if you look, you can reduce or simplify the circuit between any two terminals into one resistance in series with one voltage source. Very simple. And that's very dangerous, because he's saying that whatever the circuit is, the circuit can have like 1 million 1 million like resistance, 1 million voltage source, 1 billion like current source. Again, you can reduce all of that into one resistance in series with a voltage source. Okay? So basically, if we look into that way to the left between the terminals of the load, between A and B, if we look to the left, we can reduce all that circuit. I'm gonna highlight it into a resistance and a voltage source in series with it. We're gonna call this resistance R Thevenin, RTH, and we're gonna call the voltage source VTH. Look, we have here two sources, one current source and one voltage source. We have three resistances. Regardless, all of that has been reduced to one resistance and one voltage source. Okay? This is very powerful, very powerful. Because now, once you have this, like one resistance and one voltage source, you can determine IL, the current in the resistance RL or the load, very easily. Because IL is equal to V Thevenin divided by R Thevenin plus RL. Very easy. But of course, we don't know R Thevenin and we don't know V Thevenin. So basically, the whole idea is to find R Thevenin and V Thevenin. Once you find them, you can solve, whatever you want. Okay. So we want to find the equivalent resistance and voltage source of our circuit between the terminals of the load. So we're gonna divide the solution into two parts. The first part is to find R Thevenin. The second part is to find V Thevenin. Okay. So first of all, you should draw the circuit or redraw the circuit without the load, without the thing that is looking into the circuit. Look here. We are trying to simplify the circuit for RL. So we're gonna remove RL completely because we don't want to simplify RL. We wanna simplify the circuit that RL, is connected to, which is the one in the dashed box here. Okay. So I'm gonna copy all of that. So number one, let's get RTH, R Thevenin. Okay, so what we do to find R Thevenin? Okay, basically, R Thevenin, to find it is basically something that you already know. It's basically R equivalent. So we're gonna find R equivalent between these two terminals, A and B. So what we should do to find R equivalent here, okay? The previous lessons, when we take R equivalent, when we find R equivalent, usually the circuit has no sources. Now we have sources, okay? So to find R equivalent here, you should do something very crucial, very essential. It's to kill all the sources. To find, so the basic step here, basically kill any source you have in the circuit. We have here current source and we have here a voltage source. Okay, how to kill a voltage source? So for the voltage source, to kill it, to cancel it, to remove it, basically to cancel its job. What is the job of a voltage source? If you have a voltage source like this, it has a positive terminal, a negative terminal. It gives you a voltage E. So what it do, it makes V positive larger than V negative by E. If E is 0, that means V positive is equal to V negative. So basically you don't have a voltage source anymore because you don't have a voltage difference, correct? So the way to kill a battery or a voltage source is to cancel its, voltage output, to make the difference between the positive and the negative 0. How to do that? Put a short circuit. So we're gonna connect the short circuit like that. Okay? Once you connect a short circuit like that, you can just delete the voltage source. You don't need it anymore. So we deleted now the voltage source. Actually, let's draw it properly like that to make it easier. Good. So that's for the voltage source. So here, to kill it, put short circuit. Number 2, how to kill current source. What does the current source do? If you have a current source in a branch like that, and this current source, for example, is giving you 2 amperes, that means this branch has 2 amperes. So to cancel its effect, make an open circuit, because an open circuit always have a current equal to 0. So we're gonna bring like a cutter or something like that, or a scissors, and cut here. Once you have a cut in a branch, the current is 0. Basically, you can just remove this branch altogether. So to cancel a current source, put open circuit. Very good. Very good. Okay. Now it becomes like, what we learned before, a circuit has only resistances and we can find R equivalent. So R equivalent will be very easy here because I know, guys, you are very expert now. So you have here the 4 ohms and the 5 ohms are in parallel. Why? Because they have the same start or the same terminals and the same other terminal. Okay, so it is 4 parallel with 5 plus 9 ohms. Okay, so let's find out what is 4 and 5. So 4 and 5 is 2.22. Okay, ohms. So that's R Thevenin. Remember, this is R Thevenin. Okay, good. Second step, of course, to find V Thevenin. Okay, so again, I'm gonna take this circuit in here. And find Mr. V7. Number 2, finding VTH. Okay, so let's remove that stuff here. And A and B. So what is the definition of V7? If the definition of V7 is that it is the open circuit voltage between the terminals that you that you are looking between, or you want to simplify the circuit between. I told you Thevenin equivalent means that you can look between two terminals in a circuit and simplify the whole circuit between these two terminals into a voltage source and a resistance. Okay, so these terminals here in our case is A and B. So we're gonna consider, the connection between them open. So open circuit here means the current is equal to zero. So the current here is equal to zero. By the way, before I forgot, that wasn't the case here. Whenever you are saying that you want to find R equivalent, you always imagine there is an ohmmeter connected. So it's not open circuit. And you have to put this in your mind all the time. And I explained it in, when we take some videos and examples on how to find R equivalent. I told you always is that between the 2 points or two terminals that you want to find R equivalent between, you always imagine there is an ohmmeter. The ohmmeter is a device that measures the resistance of a circuit. Okay, good. So it's not open circuit. Now for V7, we have to assume it's open circuit. So there is open circuit now, and V open circuit, which is this voltage here, is between A and B. So I'm gonna consider A is positive, B is negative. So VEB is our V open circuit, is our V Thevenin. Once we find that, then we can, find the load resistance, the load current. Good. So let's find out. So there is zero here because we assumed it's open circuit. Let's assume the voltage here is V at that point, and let's apply KCL, Kirchhoff current law. So we have a current here going into. We have this current, 3 ampere is going into as well. Let's assume the current here is going out, and the current here is going out equal to 0. So what is the current in the 4 ohm resistor? If this is ground, and it is ground, it's given in the questions, okay, this point here will be 2 volt. Again, this is a battery. What is the battery does? It raises its positive terminal, the negative terminal, by the amount of the battery. The negative terminal has 0 voltage, so the positive terminal should have 32 volt. Okay? So the current here is 32 minus V divided by 4 ohm. 32 minus V is basically the voltage across the resistor, and divided by the resistor gives you the current. Okay, I'm sorry. This is not equal. Plus 3 equal to what is going out. What is going out is this current in here, which is V minus 0 over 5, which is V over 5. Of course, plus 0, anything plus 0 is anything. Okay. Good. So let's simplify this. So 32 over 4 minus V over 4 plus 3 equal to V over 5. So 32 over 4 is 8 plus 3. I'm gonna put the V over 4 to the right hand side. So V over 4 plus V over 5. So it's V 1 over 4 plus 1 over 5. So I can find now V. So let's use our calculator, Desmos online calculator. So we have 8 plus 3. This is all divided by 1 over 4 plus 1 over 5. Very powerful calculator. So 24.44 volt. We get V, but not V Thevenin. Okay? So to find V Thevenin, you have to apply Kirchhoff voltage law in that loop here. Remember, V is the voltage actually across the 5 volt. Okay? So let's apply Kirchhoff in that loop. So in that loop, VAB or V open circuit or VThevenin actually is going up just like the loop. So KVL at loop 1 will give us VThevenin. The voltage across the 9 ohm. So let's assume the current is going in this way. So the voltage is going in this way. But this voltage is equal to 0, which is the current, multiplied by 9 equal to 0. So plus 0. And the voltage V across the 5 ohm resistor is going up. It is opposite to the positive direction of the loop. So minus V equal to 0. So V Thevenin equal to V equal to 24.44 volt. So we have V Thevenin, we have R Thevenin. So we can solve for IL. So now let's draw the circuit. This is RL. It is 4.5 ohms. This is R Thevenin. It is how much? It is what? Oh, this is, I'm sorry, this is not 2.2. Yeah. So we can, it's 2.2 plus 9. I'm sorry, yes. 2 plus 2. Okay, so let's calculate it again. So this one is 2.22 plus 9 ohms. This gives you 11.22 ohms. This is R7, 11.22. 11.22. So that's 11.22. And the VThevenin here is equal to 24.44. So now we can find IL. IL is equal to 4.44 divided by 4.5 plus 11.22. So let's do that very quick in here. So 24.44 divided by 4.5 plus 11.22. So IL 1.55 amperes. Good, 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 good. Now, we found our I load. So let's now check on our solution. So let's resolve this question again using, just Ohm's law, Kirchhoff current law, and stuff like that. The basics, the principles. Okay. So let's take our, whole circuit now. There is no equivalent or stuff like that. And we're gonna solve it using Kirchhoff current law and, Ohm's law, and all such stuff. Good. So let's first remove that stuff. Okay. I'm gonna assume again the voltage here is V. This is a ground, guys. It's a given. I didn't draw it. So I'm gonna now apply Kirchhoff current law at V. Kirchhoff current law at node V. So let's see what kind of currents we have. We have this current. Let's assume it is going in this way. This current is 3 amperes going in this way. I'm gonna assume this current is going down and this current is also going down, which is IL. Okay. So what is the current in the 4 ohm in here? Basically, the voltage across the 4 ohm divided by the 4 ohm. So the current is going this way. So this is positive, this is negative. So that's the direction of the voltage of the 4 ohm. Okay. What is the node voltage here? This is 0. This is a battery. The battery gives the positive terminal. It raises its positive terminal than the negative terminal by the amount of the battery. So 32. So that is 32 here. So 32 minus V, that's the voltage across the 4 ohm resistor divided by the resistors, gives you the current in the resistor. This is going into, so I'm gonna add the 3 amperes because it's also going into, and what is going out is this current, which is V minus 0, because this is V here, and this is 0, so V minus 0 over 5. So V over 5. And what is this current, which is IL? This current is flowing in two series resistances. Okay? So basically, you can calculate IL in this way. This point minus this point, which is 0, divided by the two resistances. Okay? So plus V minus 0 over 9 ohms plus 4.5 ohms. Okay? You can also, combine the RL and the 9 ohm because they are series. You can combine them in one resistance and it will be like as a 5. Okay? It will be parallel with 5. Good. So now this equation has only one unknown. Okay? So 32 divided by 4 minus V divided by 4 plus 3 equal to V divided by 5 plus V divided by 9 plus 4.5. Let's bring this V over 4 here. So 32 divided by 4 is 8 plus 3 equal to V 1 over 4 plus 1 over 5 plus 1 over 9 plus 4.5. Let's calculate this. So we have 11, 8.3 is 11, divided by, that's a long one, but we're going to do it, 1 over 4 plus 1 over 5 plus 1 over 9 plus 4.5, that's 20.98 volt. So what is IL? IL from here is very easy, equal to VL divided by, or V divided by 9 plus 4.5. So look, don't guys approximate, just take this one here. This is V, correct? This is here is V. So just put it in between brackets like that and divide it by 9 plus 4 points. That's why I like to use this with online calculator. It's very powerful. Just give us what? 1.55. So IL 1.55 amperes. Let's compare it to the Thevenin, solution. It is here, 1.55 amperes. Okay? And of course, they have to match each other, you know. You might say Thevenin is like a very complicated, way to find. No, it might look like that. Might look like that. But believe me, for some, we're gonna see this actually. So in the near future videos, I'm gonna show you a theorem called the maximum power transfer theorem. And for that theorem, Thevenin is very crucial, very crucial. So we're gonna see this, in the future. Also, when you study transistors and the biasing of the transistors in the future, again, knowing Thevenin is very powerful tool to analyze circuits with transistors. Okay, guys, thank you very much for watching and see you in another video. Bye-bye.